Well, it goes back a long way. We know that Archimedes used mirrors to attack an enemy fleet, setting them on fire. By 2000, about 1000 AD, the Anasazi Indians built homes in the cliffs, and the way they used and they built these homes filtered out the high um, intense solar radiation during the summer, but it let in the lower angle winter sun, so that it was a passive heating system. And by the 17th and 18th century, scientists were concentrating the sun's rays with mirrors and lenses, and were able to melt metals. In the 1970s, we started the National Solar Test Facility in Sandia, New Mexico, and their scientists were able to melt a quarter-inch thick steel plate in just 2 minutes using their solar furnace. So those are some great achievements. Um, in the late 1800s, solar steam boilers became popular. Well, not popular, but they were invented, and they were able to produce steam to run engines, where a solar boiler provided steam to operate irrigation pumps. In this example here, now this is what was going on, was that the water is in this tube A, and this parabolic dish concentrates all the sun's energy, so the rays all point on that tube A and they boil the water. Then that boiling water goes over here to a steam engine that's able to turn the wheel and turn the knobs on the printing press. So this setup here ran a printing press, and the water is in the tank over here at C. So in the 1870s in Chile, they had a solar still. Now, I love this idea. This is great. They could provide 6,000 gallons of fresh water per day. And it's almost like a greenhouse. It's a glass glass over a tray of seawater, and the seawater evaporates, and the moisture collects on the glass, and then it runs down into a receptacle where they can collect it. And this one covered 50,000 square feet. This is the same idea here, and you could construct one of these if you ever got stuck in the middle of the ocean with no fresh water. All you need is a bigger cup and a littler cup, a piece of saran wrap and a rubber band, and then something to use as a weight. So you put the seawater in the bigger container, and you put the cup in the middle. Put the plastic wrap on the container, wrap it with the rubber band, put the stone in, and the seawater will evaporate. It'll go onto the plastic wrap, run down to where the weight is, and drip into the cup. And then you can provide yourself with fresh distilled water. We've also used solar energy for cooking. And by 1767, scientists achieved temperatures high enough to cook in an insulated box. In the 1860s, scientists experimented using a parabolic reflector, again, focusing the sun's radiation onto a cooking vessel, in this case, a blackened copper container enclosed in glass to hold in the heat. And they were able to boil water in an hour and a half. Right? So this is the solar pot. And here, this is a blackened container encased in glass to keep in the heat. Here's a parabolic reflector, so the sun's rays would shine on the reflector and on the container itself. Everything that reflects off that reflector goes onto this container. And it takes a year and a half, or an hour and a half, excuse me, to boil that water. So there were other developments. In 1870s, William Adams in India cooked meat and potatoes for the soldiers in 2 hours in January when the sun is lower in the sky. In 1950s, Maria Taux developed a solar cooker. So this is Adams' apparatus here. And the sunlight is reflected on this blackened cooking container, right? And it's enclosed in a glass jar. And here you have the reflector around it. So all the sunlight that falls within here is focused on this black container. and the glass acts as an insulator and keeps in the hot air. So he cooks for his soldiers with that.